Hello everyone, let's talk about friction in this video. Friction will resist when the object is sliding from one another, and it is a force between those two surfaces. So friction, okay, friction is a force. Okay, they are resistance. So when the objects they are sliding, okay, they are sliding to each other, or actually when they trying to slide before the movement, trying to slide, there's already frictions there. Okay, and we use S for static, K for kinetic, which is moving. Okay, so when the objects are moving, the friction between them, we call them Fk. Okay, and when they're trying to slide, so they are not moving yet, so we call them Fs static. But if you remember, when you push an object, the moment it just move, okay, when you push an object, okay, you gradually use more and more power, and when it just start to move and you feel suddenly, okay, the force becomes smaller. And the idea is for the static friction, we have a maxima. Okay, so this is the basic idea. And how big is the friction? It depends on two things. Okay, one is the material, okay, or the surface. Okay, the materials between the surfaces. And the other one is we call the normal force, or the contact force. The contact force. Okay, we can say friction is proportional to the normal force. When the normal force is bigger and the friction is bigger, so we can write a constant. We call it coefficient. Friction coefficient proportional to normal force. This is the formula we might use, okay, but might not. Okay, it depends. The idea of normal force is like this. Okay, so when you are pushing an object, so this is you, force, okay, and you will feel the friction is here, am I right, on the surface. Okay, but actually when we are drawing the diagram, okay, we draw this way, so this is your force, okay, and the friction is in the opposite direction. You don't need to draw it on the surface, but you know that the source is from the surface. And for the free body diagram, we just need to know the size, okay, and the direction of the force acting on the object. Okay, so like this. And obviously we know what, if the object is heavier and you need to apply more force to push it. I think this is quite intuitive. The reason we don't use weight, we use normal, is because I think that you remember in the previous lessons we learned, so this is object, okay, and the weight is constant, but depends on how you push the object. Okay, so if you say you pull object in this way, this is your force, and then you provide some x direction components and the y components upwards, and this way you will reduce, you make the n smaller, because these two together, Fy plus n together equals to W, n plus Fy equals to W. So normal force is smaller than the weight. Okay, and also if you push it down, okay, you push it down, and then you this is the vertical, so Fx, and this is Fy, okay, and the weight is constant, but you have what, and this is our normal is upward. So in this case, your normal will be going up will be equals to W plus what? Fy. So it will be bigger. Okay, so I think it's quite easy to understand. The more important force is the real contact force between the surfaces, and which will be the normal force. So that's why we use normal force here, and we don't say just the friction depends on the weight. Okay, so more important is depend on the normal. So how big is the friction? We can use this way to measure it. For example, I have a surface here, and I have an object. Okay, so M, and I got friction here, and I can use a spring, and I can measure the force. Okay, from the reading here, I can measure the force. Before it's moving, the object is static. So you know the friction, lowercase f, the friction is equals to the force you are applying. Okay, this is when it is stationary. Okay, so if I use the number and I put it into the graph. So this is the force you apply, and this is the friction. Okay, so if you have a smaller force and the object is not moving, so you know, say for example, you apply 1 Newton force and the object is not moving, so the friction will be 1 Newton as well. Similarly, if you apply 2 Newton and the object is still not moving, okay, so the static friction will be 2. Okay, and then we can know they are proportional to each other, so there will be a straight 45-degree line. Okay, so you gradually increase your number, and then you will find what your friction become bigger. Okay, but then suddenly the object start to move, and you feel it, the force dropped. There is a sudden drop. Okay, and this is okay. I think this one I can use red. This one. If we check the number here, and this is your kinetic friction, the force you are applying here, and you will get this number is your maximum static friction. Okay, and before under here, under the maxima, like 1, 2, 3, they are actually all one of the static friction. So in other words, static friction depends on how much force you apply. Okay, but the kinetic friction is a constant. Okay, after the object move, the friction is constant. But before it move, you need to overcome the maxima friction. Okay, so remember this diagram. So it's gradually increase, suddenly drop, and then become constant. Okay, so this is the basic introduction about friction. Oh, and I forgot to mention the friction coefficient mu. This later we read the mu, mu, and this is how we write it. Okay, so this is the conclusion of the introduction of friction.